I'm trying to think the fastest way to do this. I'm looking at the multiple choice answers, and I'm seeing, well, this one kind of does distribute the negative. So let's distribute the negative. Whenever this is a property that you should know. A property of exponents, if I have x to the power of a, and that's all to the power of b, that's equal to x to the power of a times b. So I'm multiplying the power. So what I'm doing here is I'm multiplying -1 times the 1/8, and I'm going to get k to the power of -1/8. So you are allowed to multiply powers, and that gives you b as one of the answers. There are a few answers, though. So this is not written in this fractional exponential form, so I'm going to convert that. So kind of that same formula from above. I'm going to do this number divided by this number, and this is going to be equal to k to the power of -1/8. And hey, check it out. That is exactly what we wrote up here. So that is also an answer. And C is going to be using this same property that we had from up here, where I'm going to multiply the powers. -1 times 1/8 is going to be k to the -1/8. And hey, that is again the same thing that we have up here. They're all the same thing. So the correct answer here is A, B, and C, which is probably going to be easy to memorize on your final. Just choose A, B, and C, all of them. I might have to modify the multiple choice answers that Diego gave. I'll probably give option E. I'll make that option E, and I'll make option D like all the above or something. I cannot spell above, but the answer will be that one. Anywho, we're on to Edder's quiz. So simplify I to the power of 21. The general idea here is that when you're talking about the shadow dimension, complex numbers, you're talking about the real axis and the imaginary axis. And if you go out 1 unit in each axis, you go to a distance of 1 versus I, and then if it's the -1, it's or the negative version of the real. So this is positive. Oop, I meant to do laser pointer. If I go positive, I'm this direction. Negative is this direction. So here's 1. The negative version of that is -1, right? -1. And then the imaginary goes positive this way, negative this way. So the negative version of I is down here at -I. The only 4 answers that you are allowed to choose are 1, I, -1, or -I. So those are going to be your multiple choice answers, and I'll probably throw in option E, like none of the above or something tricky. But yeah, you're only going to have one of those 4. So how do you decide those 4? Well, notice I can draw a second one to do powers. I can say anything to the power of 0, literally anything. I could do I even to the power of 0 will always give you 1. Anything to the power of 0 always gives you 1. And then if I go up a power, I to the power of 1. Anything to the power of 1 is itself. I to the power of 1 is still I. And you can keep going up powers. The definition of I squared is still -1. And then you can keep going up to a higher power. I to the power of 3 is equal to -1. -I. If you want to see why that's the case, you can really quickly say, okay, I to the power of 3 is really equal to I to the power of 2 times I to the power of 1, using those, that's not a 1, using those properties of exponents, saying that you can add these 2 numbers to get this number. And we already know that I squared down here is -1, so -1 times I is -I, right? So this is just equal to -1 times I, which is equal to -I. So that is indeed true. I cubed is -I by our example up here. And you can keep going around and around and around. This will be I to the power of 4. This one will be I to the power of 5. This one will be I to the power of 6. This one will be I to the power of 7. I to the power of 8, etc., etc. But the general idea is find a number that is divisible by 4, because 8, 4, 0, those are all numbers that are divisible by 4. And then start here and then add on a power, +1, +2, +3, +4 to their power. So in our case, we have I to the power of 21. Find a number that is close to 21 that is divisible by 4. Well, the number 20 is divisible by 4. That means, if I do this in a different color, that means I to the power of 20 lives right here. And then I can just add on a power. If I add on a power, this is I to the power of 21 lives over here. You can say I to the power of 21 lives here, and that is the answer I. So the correct answer here is I, and I'll box that. And it's just using that rule over here. Man, I'm really starting to doubt my choices for the final. Like, you just have to remember that the answer is I for that one, but maybe you'll remember differently. Your memory isn't that strong. We'll see. Anywhoosies, number 2, multiplying those 2. This is just a general rectangle, so make a box. Go ahead and divide it into 2 different parts, and then you have -4 plus 4i. I could have put that on the top or the bottom, or sorry, the top or the left. Either of those would have worked. And I get 3 plus 2i over here. Multiply, I'm going to do negative 4 times a 3 is going to be negative 12. Then I'm going to do 4i times 3 is a 12i. Then I have negative 4 times 2i is a negative 8i. And then finally, careful here, and 4i times a 2i is an 8i squared. And remember, since I squared is negative 1, that means that this whole number in here is really equal to 8 times negative 1, which is negative 8. All right, so I'm just going to add all 4 of those spots together again. So I had a negative 12, I had a 12i, I had a negative 8i, and I had a negative 8. I add all 4 of those numbers together. Every single thing inside this box, again, this one changed to over here. Every single number inside this box has been listed over here, and I'm going to combine like terms, namely the i's and the non-i's. So let's do the non-i's first. I have a negative 12 and a negative 8. That is a negative 20. And then finally, I have a 12i minus an 8i. That is a 4i. So plus 4i, and I have my final answer. Moving on to Emma's quiz. And I want to mark how the desync of the audio is. So was that right, guys? It will be now because I edited the video. You're welcome. All right. So we need to solve for x, and we're using the quadratic formula. So just as a general reminder, I am going to sing the song for you guys again. What is the quadratic formula? Well, x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. That's what we've got. And we need to find the values of a, b, and c. And it's first, second, and third. They're in the correct order. So a is going to be the first term, b is going to be the next term, c is going to be the last term, which means a is 14, b is 9, c is 10. I'll rewrite those over here. A is 14, b is 9, c is 10. We're ready to go. So we're plugging in, right? So this a goes here and here. This b is going to go here, and c is only used once. C is only used right there. So plug it in. What do we got? We got x is equal to negative. Okay, where's b? It's going to be 9 plus or minus square root. Okay, it's going to be b squared, which is going to be the quantity of 9 squared, minus 4, and then a is 14, and then c is 10. All over 2, okay, and then it goes a, so it's going to be 14. Okay, we've plugged in everything. We just got to simplify more and more and more. So we got negative 9 plus or minus 9 squared is going to be, let's write the square root first. 9 squared is going to be 81 minus, and then I got to multiply these together. I think the easiest thing to do first is 4 times 14, then we can just add the 0. So I can do that in my head, but just showing you how I'm thinking about this problem, I do it like this. 4 times 14. You guys see how I'm thinking of 14 in my head? That's going to be 40 plus 40 plus 16, Mr. Snow, my God. 40 plus 16, which is 56. So I have 56, I'll write it down here, 56, and then if I multiply by 10, which I haven't done yet, I've only done 4 times 14. There we go, 56, right? And then I multiply by 10, which just adds on a 0, so it's 560, which is really big. There you go, 560. And then that's all over, okay, 2 times 14 is 28. All right, I mean, we're basically there, just a little bit more to go. So we have x is equal to negative 9 plus or minus. All right, well, I know that this is going to be inside the square root, it's going to be a negative because the bigger number is a negative. And essentially, I'm just going to be doing 560 minus 81. And I don't like doing that problem, so I'm going to give myself an easier problem. I'm going to add 9 to the bottom, because if I add 9 to the 1, it'll come out to a nice number. And in fact, if I add 9, it'll only go to 90. Let's go ahead and add 19. But Mr. Sindel, why would you add 19? Because check it out. If I do 81 plus 19, that's 100. That's a nice number. This is going to be equal to 100. I'm doing this slow. I do this in my head really fast. So just showing you my little shortcuts. I think you guys appreciate that. You can always do the old-fashioned method and borrow. But if I add 19, to the bottom, I have to do it to the top too. Keep the I want to say symmetry, but the balance is the word I'm looking for. So if I add 19, that means I'm really at 579. And 579 minus 100 is really, really nice to do. It's just 479. No borrowing needed. So negative 479 all over 28. And I mean, you can simplify that a little bit because, as Emma did a good job explaining in her presentation, when I have a negative and it crosses this boundary, it crosses this square root boundary, as soon as this crosses through the square root, it transforms from a negative into an I. And our final answer really looks like x is equal to negative 9 plus or minus I square root 479 all over 28. And that's the answer that you should be looking for on the final. I know that you can't just remember every single number on here, so I might put 479, I might put 459. Who knows what's going to be on the final multiple choice? You'll never know. All right, the second of the two problems for Emma's quiz, kind of the same thing. I'm going to rewrite quadratic formula. Another song coming your way. Here we go. X is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And then we just got to figure out a, b, and c. So a, b, and c. Remember, a goes there, b goes there, c goes there. It always goes alphabetical. First, second, last, a, b, c. All right, so a is going to be the coefficient -3, b is going to be the 4, c is going to be the 1. I know one of the most common mistakes, and I still don't know why this is happening, is people will write, a is 3x squared and b is 4x or something. You don't include the x. Never include the x. Never include the x squared. It's just the coefficient, just the number out front. So don't make that mistake. Please, please, please. Maybe I should put that in multiple choice. Maybe someone would make that mistake. Thoughts for later. Anyway, filling in. X is equal to negative. Okay, b is 4 plus or minus square root. Okay, b squared is 4 squared minus 4. Okay, a is -3, and then c is 1. Oop, that was a bad parenthesis. All over 2. Okay, what's a? It's going to be -3. All right. And simplify. X is equal to -4 plus or minus the square root. Got a 16. Okay, so be careful here. I have a negative times a negative times a positive, which is a positive. 4 times 3 is 12, times 1 is 12, and it's going to be minus 12. Oh, that came out pretty nice. And then all divided by, remember, positive times negative is a negative. 2 times 3 is 6, -6. All right, and simplify a little bit more. X is equal to -4 plus or minus the square root of 4 all over -6. And that's going to be x is equal to -4 plus or minus 2 all over -6, and we're ready to do our two different problems. Because if you get to this point, if you come out with a nice square root, in the last problem we didn't get a nice square root. The square root of 479, I assumed it was a prime number, but maybe we should have done a factor tree to figure out if it truly was the case. It was just kind of big and I was going to give up. I'm going to pretend it's prime. It probably is prime. And not do anything. This is what's going to come up on the final, kids. Anyway, this one is a nice number, which means you have to do two different problems. The first problem, choose what happens if it's a plus, and then for the second problem, choose what happens if it was a minus. So if it was a plus, I'd have -4 plus 2 over -6, and if it was a minus, I'd have -4 minus 2 over -6. So top would simplify to -2 over -6, which would simplify to +1 over +3. That is one of the two answers. And this was going to turn into -6 over -6, which simplifies to 1 over 1, which is just 1. So your two answers are a third and 1. Cool. And I think I'll probably write it a little bit more formal than this. I'm doing it for all my other classes as well, just so you can see what it would look like in a textbook if you studied math in college. Technically, you'll say x is equal to the set of numbers, so curly brace, and the numbers that are in x, you have a 1/3 and you have a 1, and then you end your curly brace. It looks a little bit more formal, and I'm sure Kira would approve. That's probably closer to what she was seeing when she was studying math in Europe. We got Esh's quiz. Let's mark for desync and move on. So very similar to Alden's rationals, but this is just with polynomials. There's no denominator. So the word zeros means the same thing. It's where the top is set equal to 0. Well, this is all divided by 1. So the top being set equal to 0 means that's set equal to 0, that's set equal to 0, and that's set equal to 0. You can actually set it equal to 0, but a much simpler way is to ask, all right, there's my term. What number do I plug in for x that will make this whole thing 0? Well, if I plug in -4, the -4 plus 4 will give me 0. So that means x is equal to, I have a -4 is one of the answers. What number would I plug in here for this x, right? Well, if I plug in a 7, 7 minus 7 is 0. So 7 also works. And what about over here? Well, what number would I plug in? This one is a little bit tricky, but I think you can find it. You could find it with guess and check. What number would you plug in for that x? Well, you could plug in, if I plug in a half of 2 is 1. I want it negative though, so maybe it needs to be -1/2. Yeah, and that is indeed the answer, -1/2. And if you can't do that logic, kind of like I'm doing in my head, you can just set an equation. You can say this whole thing inside the parentheses, this 2x plus 1, set that equal to 0 and find where that's equal to 0. And then you can just solve it. You can say, okay, -1 minus 1, that's going to leave you with 2x is going to be equal to -1, and then I'm going to divide both sides by 2, divide by 2, giving me x is equal to -1/2, which is what we found. So there's my answer over here. I'll go ahead and box it. Ooh, that was a terrible box. I can, try again. Find the multiplicity of all the zeros. So I'm just going to be lazy. I'm going to do lines. I'm going to say, okay, that one and that one and that one. The multiplicity just means what power were they? This one was a power of 3 for the 4, so it's a power of 3. This one for the 7 came from this one right here, which had a power of 8, which means that 8 is going to come down here, and we're going to say that one was a power of 8. And this -1/2 came from this one, which had a power of 2, which means our multiplicity is 2. There we go. Not sure how I'm going to turn that one into a multiple choice question. I'm probably have to combine them all into multiple choice questions. I think I can see how this is going to work. All right. This one. Ooh, this one is going to be a fun one to make into a multiple choice question. I'm going to write circle select all problems that could potentially be a graph, or could be equations for this graph. So the most important thing is that you should have 3 zeros. You should have a 0 there, there, and there. So somehow you need to have like an x plus a 3. Why plus 3? Well, because if I'm doing, what number do I plug in for this x to make this whole term 0? I plug in a -3, which happens right there at -3. So you're kind of doing the opposite of that number, right? This number right here is a half, or sorry, this number right here is a -1/2. So the opposite of -1/2 is +1/2. So some people did different options, and I'll show you both of them. Some people did x plus a half, which is correct. But some people did this equation. So here's your first equation. Y equals that. Your second equation, by the way, I'm not done. I still have another third term. But let me just explain this before I move on. Some people still have x plus 3, but they did this, which is I consider to be much more crafty, much more intelligent. They did 2x plus 1. And I'll show you why that's cool. Because you still have to plug in -1/2. Again, -1/2 will be plugged in here. -1/2 plus that 1/2 does give you 0, but watch what happens if I plug in -1/2 here. It still gives you 0. If I plug in -1/2 here, I think that's exactly like what happened up here. It's exactly what happened right here. That one gave you -1/2 for the same reason. So if I plug in -1/2, 1/2 of 2 is 1, and because this was a negative, this will be a negative times a positive, which is a -1. This whole thing is -1 plus 1 is 0. So it works, right? And then finally, we need this last 0 over here, which needs to be a +3, which means we need a -3. We need an x minus 3 or an x minus 3. And if you're being over the top and dramatic, you can go like this. This is something that might come up in the multiple choice too. I can do a 3x plus 9. Sorry, minus 9. Because technically that still works. Watch. If I plug in a +3 into this, I get a 3 times 3, which is a 9. 9 minus 9 is 0. So that still works. You can just make sure that that whole thing equals 0 when I plug in that x-intercept. X-intercept and zeros are the same thing. All right, so that is half of what you're supposed to do. The next half is you have to make sure that the multiplicity is correct. And the general idea here is if it crosses the x-axis, in which case those two both cross, then it's going to be an odd multiplicity. Again, if you don't like the word multiplicity, you can kind of cross it off and think of this as the word power. or exponent. And then over here, this one turned around, I guess. Turned around. It turns around if it has an even multiplicity. And again, you can think of that as the word power. So that means that for these first two, they should have odd powers, and this last one has to have an even power. So you could go, what's an odd number? 7, 9, okay, then I have to have an even power. 108, cool, sure, why not? And then this next graph needs to have, again, odd, odd, even. So what's an odd number? 1. And if I don't put anything, you assume it to be 1. So I'm going to not put anything there and be a little bit tricky. And then for this one, I'm going to do a cool odd power, like, I don't know, what's a 21 is an odd number. And then an even number, 6, sure, doesn't really matter. So both this equation and this equation are potential graphs, or potential equations that represent the graph to the left. There's an infinite number, right? I could have chosen 23 or 25 or 29. It doesn't matter as long as this is odd, this is odd, this is odd, this is odd, and these are even. And also I can have a bunch of different factors. I could have done 2x minus 6, 3x minus 9, 4x minus 12, x minus 3. There's so many different factors that will make it so that 3 is a 0. There's so many options here, which is why I think I'm going to have a lot of fun making the multiple choice question for number 2. Moving on to Giorgio. Let's go ahead and do the desync tracker. And that should have lined up now with the editing of the video. And this is very similar to Escha's. I'm glad that they're alphabetically similar by first name because they're both talking about an analysis on polynomials. For he's drawing a stick figure for n behavior. So n behavior, you're looking for the highest power. That's power 5, 2, 7, and 0. So 7 is clearly the biggest. So I'm going to scribble out everything else. I don't need anything else. Scribble. Notice that I'm not scribbling out the sign. The sign in front of the term is part of the term. And scribble. All right, so essentially, I'm only talking about negative 6x to the power of 7. So the first thing that I notice is that it's negative. And the next thing that I notice is that the power, maybe I'll do a line a little bit over here. There we go. Next thing that I notice is that the power is odd. Those are the only two things that you really need to take away from the leading coefficient. Again, if the polynomial is written in standard form, usually this leading coefficient is actually in the lead, but he purposely wrote it in non-standard form, making it a little bit of a trick question. So I appreciate that. I'll throw that in the final just the way that Giorgio wrote it. So the power is odd and it's negative. So first of all, I'm going to talk about the negative versus positive, because generally speaking, if I have a stick figure, let me talk about the difference between, I'll call this one positive versus negative. A positive means my right hand is up, and a negative means my right hand is down. It's all about that hand, right? Up or down. And the next thing that I have to figure out is the power if being odd versus even, right? So if I have odd versus even, odd just means they don't match, so not the same. So you could have stick figures like this, or you could have stick figures like that. And then if it's even, they are the same. That was a bad E. Meaning I'll have a stick figure like field goal, or I'll have a stick figure, terrible stick figure, like that. And since I'm here, I can already do the analysis. Look at the right hands, right? If I look at the right hand on this one, it's positive, that one's negative. Positive, negative. Kind of nice. All right. So we have a negative. I'm looking at this, right? We have a negative here, meaning that we have a stick figure where our hand is down. And then finally, we have a power that is odd, meaning we have a mismatch. The hands are not the same. Oop, didn't mean to double tap that. And that means I have a hand that comes up like that, and that is our final answer. Moving on to number 2. Okay, so signs, this one is difficult. The first thing that I recommend is making a number line. I mean, you're not going to have a number line on the multiple choice. So you need to make your own. Definitely still good advice. So make a number line. Nice. And you need to find all of the zeros. So we have 3 different terms up here. Each of them gives you a unique 0. You'll get a -1, a -6, and a -3 as the potential zeros. Why? Because what number do I plug in here to get this whole thing to be a 0? Well, -1 plus 1 is 0. What number do I plug in for this x to make this whole thing a 0? -6. Same thing over here. Same logic, right? So let me go ahead and label these zeros down here in the number line in the correct order. I start with -6 because that's the most towards negative infinity over here. So this is going to be a -6, then it goes to a -3, and then it goes to a -1. Those are the zeros. And then I need to figure out, am I positive or am I negative? And to explain this a little bit more thoroughly than what Giorgio did, remember that really what we have is we have a coordinate plane. We have an x and we have a y. What I've only done is I've drawn the x-axis. I have not drawn the y-axis. We leave that off. We will eventually have something, some graph that kind of looks like this, right? Something that looks like that. The whole point here is we don't care exactly where the line is. We just care, is it up here or is it down here? We only care if it's positive or if it's negative. So we go ahead and we totally ignore that line and we only focus, am I up or am I down? And if you choose a test point right there, like anywhere in between the interval, and plug it in, you'll see if you get a negative or a positive value, which is all that he's asking for this problem. So let's go ahead and do test values. So I'm going to start as easy as possible. I'm going to start on the right because that's a nice number. I'm going to do a test value of 0. 0 is to the right of -1. And if I plug in this 0 into all of these x's, I can figure out if I'm positive or if I'm negative. So let's do that work. I want to actually keep this. So f of 0. When I plug in 0, I'm going to get 0 plus 1 times 0 plus 6 times 0 plus 3, which is going to be a positive times a positive times a positive, which you've guessed it, is positive. Cool. So that means over here, I have something that happens, it's like going up like that. But the thing that I'm going to write, I'm just going to write a positive. And I'm going to write it on the top side. If it was a negative, I would have written it down here. Okay, now I'm going to do a test point in between -3 and -1. I could choose any number. I could choose -1.1, but I'm going to choose a nice number. I'm going to choose -2. Any number in between -1 and -3 will work. And let's test it. When I do f of -1, what do I get? I'll get -1 plus, or sorry, why did I do -1? I said -2, and I wrote -1. f of -2 is going to be -2 plus 1 times -2 plus 6 times -2 plus 3. All right, -2 plus 1 is negative. -2 plus 6 is positive. -2 plus 3 is positive. Let's do these one at a time. A negative, I want to do this with a red laser pointer. A negative times a positive, well, let me do this one first. A positive times a positive is a positive. This positive times this negative is a negative. So I'll say is negative. So that means over here, I have a negative value. All right, I have to keep going all the way. I need to figure out that one, and I need to figure out that one. Well, do I? Let's read the question. What is the sign on the interval just between -6 and -1? So between -6, between there and there. Okay, so I'm only looking at these two intervals. I guess I didn't really need that one. I just need this one, and I need this one, and then I am done. So this is the last one. What's a good test point? Anywhere in between. I'm going to do like -4. Why not? -4. So when I plug in -4, I'm going to do f of -4. Let's see what happens. This is going to be -4 plus 1 times -4 plus 6 times -4 plus 3. Let's check if these are positive or negative. -4 plus 1 is negative. -4 plus 6 is positive. -4 plus 3 is negative. Okay, I'm going to do these two negatives first. Negative times negative is a positive, times a positive is a positive. Therefore, our final answer is positive. That means over here, our answer is positive. And so what is the sign? Again, let me read the question again, right? What is the sign between -6 and -1? So the question has options. It's either going to be always positive, like if both these were positive, then the answer would have been positive. If both of them were negative, you'd say the entire interval is negative. But since we have a mix, you want to say it's a mix, and it depends on what the multiple choice is here. And since I am in charge of the multiple choice, you have to be ready to say it's a mix. So our answer is going to be positive on -6 to -3 and negative on the interval from -3 to -1. That's the full answer that you should be ready to write. And I'll probably have some mix like that. I know in Khan Academy it says only positive, only negative, or neither, but I'm not going to do that. I'm gonna have something a little bit more specific since I'm in charge of the multiple choice. Excellent. Moving on to Ugo. Let's do the time sync check. That should be lined up after my video editing. And I love these. These are just kind of like straightforward algebra, just using some new tools. Solve for x, that classic question, right? So the general idea here is you're using PEMDAS. You're using my please excuse my dear Aunt Sally, where multiplication and division are in the same rung, addition and subtraction are in the same level of importance. So do I see any addition or subtraction to undo? I see multiplication, a power, multiplication. Okay, none of you. Do I see any multiplication or division? I see 2. I see 3 times x, and I see 0.3 times e. Well, the problem with this 3 times x is I can't just divide both sides by 3 because it's trapped in the exponent. It's trapped up here in this higher level. And to undo, to solve for x, you always do this direction. From the bottom to the top is solving for x, which means I first have to get rid of this one first. So I'm going to divide both sides by, and I have plenty of room down here, so I'm going to rewrite the problem. I'm going to say 0.3 times e to the power of 3x is equal to 27. I'm going to divide both the left side and the right side by 0.3. And that will now cancel out. Those are gone, leaving me with just e to the power of 3x is equal to, all right, well, I have a calculator, and you will have a calculator on the final as well, so you might as well learn how to use it. So let's go ahead and open up a calculator. All right, we don't need it that big. We can zoom over there. Okay, 27 divided by 0.3 is 90. So we can come back over here and say 90. Okay, now I need to somehow do something that will move this whole 3x down here into the, from the exponent into the base. The only tool that we know in math to do that is the logarithm. We're going to take the log of both sides. So what I need to do is I need to move this 90 a little bit to the right so I have room to write my log. So I'm going to take the log of the left and the log of the right. And this is the cool thing. You get to choose whatever base you want. And the smartest thing to do is choose this number, the original base of the thing we're untrapping. Choose that number to be the base because it makes your life easy. You'll see why in a sec. So I'm going to choose base E. Base E for both. They both have to be the same thing. This base and this base. Same thing, right? So when I take the log, you now have permission to take this 3x and move it down into the bottom. So let me rewrite this. We now have 3x times the log base e of e is equal to, and by the way, I should mention that log base e is the same thing as the natural log, which we write ln, which, I mean, I've pointed out before, that seems backward. It's natural log in terms of the letters, but it's Latin, so it's backwards, kind of like Spanish is sometimes backwards in terms of the adjective and noun joining. So the natural log of 90. Okay, so why was it nice to choose base e when this was an e right here? Here's why. A log is really a what power function. What power does e need to be raised to get e? E needs to be raised to the power of 1 to get to e, so this whole thing is 1. This whole thing cancels out, and I'll do this permanently. This whole thing turns into a 1. And as you already know, 1 times 3x is just 3x. So really I have Now a 3x is equal to the natural log of 90. And I do my natural logs with a cursive L right here because I don't want to accidentally confuse it for a 1. My 1s and L's look exactly the same. So then I just divide both sides by 3 and I'm done. Divide by 3, and there's 2 boxes here, and I don't know how I'm going to do this on the multiple choice yet, but I'll figure out a way. That means this first box is going to be the natural log of 90 divided by 3. That's the exact expression. And then now that if we enter it into a calculator, we'll get the approximation value. So I'll say the natural log is a function, I think, ln, there it is, natural log of 90, and then I'm going to end the parentheses, then divide that by 3. That's going to be, it's basically 1.5 if I'm rounding to 3 decimal places. So this is 1.500. Or I'll just leave that as 1.5. Cool. That's the answer that you're looking for. Let's try the next one, number 2. Same thing as before, using reverse PEMDAS. I need to get rid of that 20 first, so I'm going to divide both sides by 20, but let me rewrite the problem. I have 20 times 7 to the power of 3y is equal to 5. And I'm going to first divide both sides by 20, divide both sides by 20. And I'm just now realizing all the way like halfway through the video that on the final, and I'll already explain this in class, but I should have this in the video as well. On the final, you get 2 points per question. In this question, all of this work is 1 point. You have to have the correct work. And then you get a whole point for the multiple choice letter, which means you can get all the work correct. You'll know the answer is like 3, and then you'll bubble in the answer for 5, and then you'll get a point off because you bubbled in the wrong letter because you're being silly. So point for bubbling in the correct letter, the correct answer, and a point for showing all of the correct work, which I should give more points for showing work because that's where the hard work comes in, but I also want to make this easy for myself and give it all or nothing, make it easy to grade. Anyway, back to the problem. The 20 and 20 do cancel each other out, leaving you with just a 7 to the power of 3y is equal to 5 over 20, which is, I mean, you can leave it as 5 over 20, or you can simplify it to 1/4. Or if you want to do decimals, you can say 0.25. It's your choice. Whatever floats your boat or sinks your sub. So now we need to get this 3y down here, and the only way that we have to do that is to take the log. So I'm going to move this 4 out of the way so I can take the log of both sides and say, okay, I'm going to do this in red. Whenever I do something new, I usually switch colors. So I'm going to do the log of the left and the log of the right, and I get to choose whatever base I want. I'm going to copy the base that I have right here. So I'm going to do a base of 7. I want that to be permanent though. Base of 7, and I have to do that to both sides. All right, so now I have permission to move this 3y down in front. So I'm going to rewrite my problem. Oops, whoa, what did I do there? Oh, I clicked on a different file. So now I'm going to come back over here and I'm going to rewrite my problem as 3y times, that's going to be log base 7 of 7 is equal to, that's going to be log base 7 of 1/4. Cool. And again, you want to be thinking of a log function as what power does 7 need to be raised to get to 7? Well, 7 to the power of 1 gives you 7, which means this whole term here evaluates to 1. So really, I just have a 3y is equal to, okay, and I don't want to keep rewriting this log base 7 of 1/4 because I'm going to have to evaluate that and check it out. On the calculator, on most calculators, you can't do log base 7. If I try to do a log base 7, log, and it doesn't even let me, log base 7, is it going to let me do base anything? Sometimes it'll let you do base. It doesn't even look like it lets me do that. Yes, it doesn't let you do a base. It only has the normal logs. So how do I do that? You're going to do the change of base formula. And as a reminder how the change of base formula works, I'll label this the change of base formula. Generally speaking, if you have log base A of B, you can do any log, you can change this to any log that you want, any new base. So I'm going to do log of whatever you want, log base x. And you could change that to e, 10, whatever you want. Normally, we'll do 10 because your calculator over here on the right is base 10. So it's going to be log of whatever you want of the top is always going to be the inside, all divided by log of the same base as you chose on the top of the bottom, so of A. So over here, I'm going to do that change of base formula, and I'm going to say that this is really going to be the log base 10, which means I don't need to write the base. If ever I do base 10, that is assumed that is base 10 if I don't write it. So log of 1/4 divided by log of 7. That is the change of base. And now I can actually enter this onto a calculator. But I'm not done solving for y. I still need to divide both sides by 3. So divide by 3. Oop, that's a 7. Divide by 3. And divide by 3. So you have to be a little bit careful. If you know your properties of fractions really well, you don't have to do too much work. But I'm going to do this the long way to really show what's going on. Divide by 3. So whenever I divide, I'm really doing a keep it, change it, flip it, right? So this is going to be equal to keep it, log of 1/4 divided by log of 7. Keep it, change it, flip it, which means that 3 only belongs in the denominator. And normally people know that. They say, okay, if I divide by 3, that means that this 3 just kind of goes down here as well. But I'm just making sure everyone knows why that is the case. So that is a long-winded way of saying that our answer is log of 1/4 divided by 3 times log of 7. Just got to enter that into the calculator. So log of 1/4, all of this divided by 3 times log of 7. And that is going to be equal to, well, I guess approximately equal to, because we're rounding, negative 0.237. 237 final answer. Nice. All right. And our next problem, I don't want to use a calculator, so I'm going to go ahead and go like that. Let's go ahead and check the sync for the sound. That should now line up after the video editing. And Hazi chose nice problems from my homework, which this is a compliment. Like, what is the mimicry is the best form of compliment? I don't know the phrase, but thank you, Hazi. The equation of the midline, this number will always affect the midline, and it's always going to be y equals. So y equals that number, -2, just pretty straightforward. Amplitude can never be negative, but it's always coming from this number down here is the amplitude. It's just a number. There's no y equals. If you put y equals 3, you're wrong. It's just 3. Right, and again, you can't have the negative because amplitude is a distance, and distance can never be negative. And period is also distance, so it can never be negative, so you can kind of ignore the negative for this period question. And then this one is the only tricky bit of Hazi's quiz, and it comes from a formula that you'll have to memorize. It's not going to be given to you on the final, nor was it given to you on the quiz, so that's good practice, right? The period is a formula given by that number. I'm going to call this number here b. It's the number in front of the x. So the coefficient of the x in this case is -1/4. Again, ignoring the negative, but really, so b is 1/4. I'm going to do b. What's going on here? I'm going to say the period is 2 pi over b. 2 pi divided by b. I'm pretty sure that's right. Yeah. So that means in our case we have 2 pi divided by 1/4. Again, ignore the negative because period can only be positive. It's a distance. Right now, I really have a fraction within a fraction. I have 2 pi over 1 divided by 1/4. So I'm going to keep it, change it, flip it, and I get 8 pi for my period. And exact same thing for number 2. Equation of the midline. Midline will always be y equals, and then it's going to be this number come down here. It's going to be 5. Amplitude is going to be this number just down here. It's going to be 11. And finally, the period is going to be 2 pi over b, which in this case, that is a b. It's going to be 2 pi over 2 pi. And you can think of the pi's and pi's canceling each other out. 2 and 2 also cancel each other out. That is just equal to 1. Equals to 1. And box it. Did I box the last one? I did. Good job, Mr. Snell. Oh, that is one of the easier quizzes, isn't it? And let's move on to the next one. I don't think I need to do a check for the time sync. So for this one, the instructions aren't quite correct. I'll go ahead and fix that in our final, but it just means completely factor. Completely factor this one, and you will have to start by factoring out the greatest common denominator factor. That is the first step, but it's not the entirety of what he's asking for. So what is the greatest common factor? What can I evenly divide each of these by? Like, I don't know, can I divide all of them by 6? No, can't divide. Okay, I can divide them all by 3. So check it out. If I divide each of them by 3, that means 3 is being pulled out, and that leaves a 2x squared, that leaves a minus 5x, that leaves a minus 3. All right, so that was the first step, and I still need to factor this inside more. So I'm going to need an advanced ninja star. So let's go ahead and draw that off to the side here. So the way that the advanced ninja star works is I take this number and I multiply them. So 2 times negative 3, that turns into a negative 6, and they come up here, negative 6. I take the coefficient negative 5, bring it back to the bottom, so this is a negative 5. And then I take this number and this term, and they both go here and here. So it's going to be 2x and 2x, 2x and 2x. Then you get to ask the fun question, what two numbers multiply to negative 6 and at the same time add to negative 5? And it's pretty straightforward. You can just go through all the factors. The first one that I always start with is 1 and whatever else, and that actually happens to be the answer in this case. I'm going to guess 1 and 6. 1 times 6 gives you 6, and one of them has to be negative, so I'm going to choose that one to be negative. And 1 times negative 6, you're just checking. 1 times negative 6 does give you negative 6, and 1 plus negative 6 does give you negative 5. A lot of people will start to get confused, like 2 and 3, they don't work because one of them has to be negative, and then you can't get negative 5. Yeah, well, that's because those aren't the answers. It's 1 and negative 6. Okay, so we solved the ninja star, but now we have to use the ninja star to treat this as a fraction and this as a fraction and simplify those fractions. So left fraction simplified is just 2x over 1. Can't simplify that one. But this right fraction, I can divide both the top and bottom by 2. And that means I'm going to simplify by turning this into x over negative 3. Nice. So those are the answers. Don't forget that that 3 is going to be brought down still again. So that's going to be 3 times, and then I have this 2x minus 1 is going to come down here, right? So I'm going to have 2x plus 1. And then this x minus 3 is going to be brought over here. So I'm going to say this is going to be x minus 3. And there is our final answer. We will box it. Next, we have number 2. It's a little bit clearer that you should be factoring a greatest common factor. What can you evenly divide all 3 of these factors by? These terms by? Well, you can divide all of them by 3, and that should be pretty straightforward. 18 divided by 3 is 6, so that still does work. And you can also factor out another thing. You can factor out a variable, b to some power. What power can you choose? Well, you typically choose the smallest one. You have a 5, 4, and 3. Well, 3 is the smallest one, so 3 is going to come down to each of these. b to the power of 3 is what we're going to divide out by. So that means that is 3b to the power of 3. That is the greatest common factor, which we are factoring out. When we divide those out, what are we left with? Well, 3 and 3 cancel each other out, so there's no number out front. And then you're going to subtract the powers. 5 minus 3 is 2, so I'm really left with b to the power of 2. Okay, 15 divided by 3 is 5, so this is going to be a positive 5. And then I subtract the powers. I have b to the power of 4 minus 3. 4 minus 3 is 1, so b to the power of 1, or just b. Finally, again, I'm going to copy down the sign, copy down the minus sign, and 18 divided by 3 is 6. And notice that b to the power of 3 minus, or b to the power of 3 divided by b to the power of 3, those are just gone, and I'm just left with 6. And then this inside is just a normal ninja star, or you can use an advanced ninja star, which will still work. So ninja star, I have a negative 6 and a positive 5. What two numbers multiply to negative 6 and add to 5? Let's try 1 and 6. Does that work again? I think it does. 1 and 6, if I make that one a negative 1. So it's a little bit different. The last one had a negative 6. This one was a negative 1. And that means our final answer is going to be 3b to the power of 3. We have an x plus 6, and we have an x minus 1. Final answer, and box it. Very nice. All right, moving on to Kira. Geometric series. All right, so let's do a time sync check. And let's solve. So every single one of hers has a formula that goes along with it. You just have to have it memorized. So here's your formula. Your sum is equal to the first term times this fraction. And this fraction is going to be 1 minus the, I'm going to call it the multiplier, to the power of, I'll call it the number of terms, and then all over 1 minus the multiplier. A lot of people, I don't want to say a lot, some people make the mistake of saying, okay, this whole thing is in parentheses. That's not true. The only thing that's in parentheses is this is in parentheses. So it's going to be the multiplier just to the power of that number. All right, so we got to figure out all of these things. I'm realizing didn't give enough room to analyze the problem, so I'll move you down a little bit. What do I multiply by to go from here to here? By the way, I know that I'm multiplying because it's named geometric series. Geometric means repeatedly multiply. And I know at first glance it seems like, oh, well, the answer, Mr. Snell, is I divide by 2, and then I divide by 2. And you're correct. That is correct. You are dividing by 2, but you have to think about this in terms of multiplier. Otherwise, the formula will not work. So in order to get from one step to the other, you have to multiply by a fraction. You multiply by a half. Or if you don't like a half, you can think of this as a decimal. You're multiplying by 0.5. If I multiply by 0.5, multiply by 1/2, repeatedly over and over again, you'll get the next term, your next term, etc., etc. So if I want the fourth term, I'll multiply by a half again, and I'll get 8. And I could multiply by a half again, and I'll get 4, and then I'll get 2, and then I'll get 1, etc., etc. And you could do that for the first 9 terms. How many do we have so far? We have 1, 2, 3, 4, 5, 6, 7. We need 2 more. So technically, here's a little easier way of doing this, plus a half, plus a fourth. You could just add those numbers on a calculator, and you're done. That would be nice. So what Kira maybe should have done is done like first 90 terms. So it's not impossible to do it this way, but you could totally just do it that way and be done with it. Let me show how to use the formula, because the formula is definitely going to be needed to do number 2. I think it's going to be used. You could use guess and check, but it's faster to use the formula. So the multiplier is 1/2. So multiplier is a half. We know what the first term is. The first term is 64. And how many terms are we at? This number is 9. So check out what's going to happen. The sum that I'm after is going to be the first, which is 64. It's going to be multiplied by this fraction of 1 minus the multiplier, which is a half. That's going to be to the power of 9, because it's 9 terms. That is supposed to be a 9, all over 1 minus a half. That's it. I just enter this in the calculator, and I'm done. So I guess I need my calculator back. So press on this, go to the calculator tool. So I'm going to have a fraction, so I'll set up the fraction, and I need a 64 out front, so 64, and then top of the fraction is 1 minus, and then I'm going to start my parentheses now. It's going to be 1/2, and then that's going to be to the power, I can end the parentheses, to the power of 9, and that's all going to be divided by 1 minus 1/2, and I get 127, this is, I'll write down, 127.75. Nice. And then I move on to our next problem. So it's telling us all of the pieces of the formula. So let me rewrite the formula. The formula is that the sum is equal to the first times the fraction of 1 minus the multiplier. I'm just going to abbreviate 1 minus the multiplier. The only difference is that the top has a power of some number. So we know that the common ratio is 333. Oh, this is the mistake, because when you copy and paste from Khan Academy, it does 3 of these numbers. So really what should happen here, let me use some fake whiteout. Let me change this to white, and I can scribble this out in a slightly thicker pen. The common ratio is 3, and the sum of the first 8 terms is 3,280. So now this is the correct problem. I'll switch this back to black and change it back to thin. Okay. So now this is the correct problem that you guys have in your quiz as well. And we just fill in to the formula, right? So we already know that the sum, the final answer is 3,280, which we're going to plug in over here. So that's going to be 3,280 is the sum. It says, we don't know the first term, so I'm going to leave that as a variable. I'll just call it f for first, times, and then it's going to be that fraction, and I'm running out of room, so let's scoot you guys down a little bit. It's going to be times this fraction of 1 minus the multiplier. What is the multiplier? What do we multiply by every single time? Well, technically it's not called the multiplier. It's called the common ratio, which I don't like the word. I understand why people use it, but really common ratio is the multiplier. That's what you multiply by each time to get to the next term. So if the multiplier is 3, that means I'm going to come back in here and say that's going to be 3. That's going to be 1 minus 3 in the bottom as well. The only difference is that the top is going to have the number of terms, and it says the first 8 terms. So 8 is going to be that number right there, which means it's going to be this number down here for that power of 8, and then I just need to solve. So what I'm going to do is I'm going to enter all of this on the calculator, and then I'm going to do 3,280 divided by that number that I find on the calculator. So enter this first. I have what happened over here? So come down here, I have a fraction, and it's going to be 1 minus 3 to the power of 8 to the power of 8, all divided by 1 minus 3. Oh, I did 1 divided by 3. 1 minus 3. Cool, it's 3,002. Wow, okay, well that was nice. Let me rewrite what we've got so far. We have 3,280 is equal to f times 3,280. Divide both sides by 3,280. Divide by 3,280. Divided by 3,280. And we've solved for f. Oh, I should do that in blue. F is equal to 1. The first term was 1. That's probably an easy number to remember for the final. Nice. All right, I think I'm done with the calculator for now. Let's move on to the next question. Do the audio sync check. And here we go. So polynomial division, the way that Ulysses taught, is the fastest and most efficient way, although it doesn't work on all problems, but it works on all of his problems, so it works out. All right. So he uses synthetic division. The general idea for synthetic division is you take the denominator. It should always be a normal x, not a 2x, because then it wouldn't work. A normal x and then minus or plus a number. So you take the opposite of this sign and the 2. So I'm going to have a plus 2 here. Plus 2. I'm going to put that up here. That is going to be my number that I'm going to multiply by over and over again. And then I'm going to give myself room up here to write numbers. I'm going to give myself room to write numbers under here and room to write numbers right here. So the numbers that go right here are the coefficients of this problem. And you have to be careful because your coefficients should always go like this. It should always go x to the power of 3, then x to the power of 2, then x to the power of 1, then x to the power of 0. It should always go in that order. And by the way, x to the power of 0, usually we just cross that off and we say that's nothing, which means it's just the number. This is the constant term. So do we have each of these values? And just check. We have an x to the power of 3. Yep. X to the power of 2. Yep. X to the power of 1. Yep. Do we have an x to the power of 0? No. We should have like a plus 2 here or something, but we don't have that. So what I'm going to do in my problem is I'm going to say plus 0 to make it easier for me to remember. There should be a number there. Okay, so now that I have placeholders for all of these powers that I'm looking for, I'm going to write their coefficients. I have a coefficient of 1, then a coefficient of 6, then a coefficient of -5, and then a coefficient of 0. You have to have all 4 of these which match these up here, right? Okay, then you're just following the procedure, which, I mean, it's one of the reasons I don't like the shortcut methods. Like, why do you use that procedure? Well, it's hard to explain unless you look at the long division, which takes a lot more work. So the first step in our procedure is bring this one directly down and just copy it down. Cool. Every single time that you pass this barrier, if you pass this barrier to the top right, you have to pay the tax by multiplying by 2. So pay your 2, or multiply by 2. 1 times 2 is now 2. Every time that we went like that. So maybe I can do arrows so that you guys can follow it. And then you just add them straight forward. So go 6 plus 2 is 8. Okay, then again, I'm going to cross that border. I might as well just use pen. Every time that I cross that border to the top right, I have to multiply by this number over here, times this 2. That's going to be 16. Then you just add them straight down. 16 plus -5 is 11. Oh, look, I'm crossing the border again, which means I have to multiply by this number that I left up here in the box. So 11 times 2 is 22. And then I add them straight down. 0 plus 22 is 22. And there's basically my answer. So that last number is always going to be the fraction. So it's going to be 22 divided by whatever number I was originally divided by, in this case, x minus 2. So this x minus 2 is going to come down here, and I'm going to write this as x minus 2. This number is going to be the constant without any x's. This is going to be the 8x term. This is going to be the 1x squared term. If I had a number right here, then that number would have been the x cubed term, but I don't have that, so I can just end right here. Notice that this was a positive 8, which means I have a plus. This was a positive 11, which means I have a plus, and I can write my final answer. There it is. Oh, wrote off the screen a little bit. Nice. All right, let's do another synthetic division problem. This one is nicer because he did not skip any values. Just remember that you should have an x to the power of 3 term, an x to the power of 2 term, an x to the power of 1 term, and an x to the power of 0 term. In this case, we have each of those. We don't need to skip any. So same procedure as before. We take this term, which is -5, we make it into a +5. That is going to be the thing that we pay taxes for, to cross that boundary line. So there's that boundary line. I'm going to go ahead and rewrite the coefficient. Coefficient of 5 comes first, and we have a coefficient of 5, then -22, then -17, and then +11. All right, so first step, bring the 5 directly down, and we have a 5. We pay to get over this line. I don't know why I keep going to laser pointer. I just love the laser pointer, I guess. Every time I cross that line, I have to multiply by 5. 5 times 5 is 25. Add them straight down, 3. Okay, I'm crossing that boundary line again. You got to pay 5, so times 5 is 15. Add straight down, you get a -2. Cross the boundary line again, -2 times, again, it's -2 times this 5 gives us -10. -10, add straight down, I get 1. All right, so that last number is always going to be divided by this x minus 5. So I have 1 over x minus 5. And then I have a -2, and then I have a 3x, and then I have a 5x squared, and I have no x cubed term right here, so that is just it. That's my final answer. Well, that's it for our quizzes then, because we ran out of quizzes to take. So we're at this point in the video. Thank you for watching the video until the very end. You guys are doing a good job preparing for the final. You guys do have the easier of the finals since you took so many other tests, so congratulations. And I will